Good use of AI alert, let's talk about it. Antibiotic resistance is a huge threat to human health. 5 million people die every year due to infections with bacteria that are too buff for antibiotics. The issue is, every time we hit bacteria with chemicals designed to kill them, we're essentially poking them into evolving new ways to survive that chemical. So we need to be constantly tweaking our drugs to stay one step ahead of evolution and maintain our bug-killing arsenal. And scientists have just used generative artificial intelligence to design a fresh batch of chemicals that can kill bacteria completely from scratch. Starting from building blocks as simple as water, ammonium, and methane, scientists generated a library of 30 million new molecules. This insane number was then narrowed down by other AI models that predicted how well they would function as a wrench thrown into a specific bacteria's inner machinery. And their models also predicted a lot of other important stuff, like how easily these molecules could be synthesized in a lab, how likely they were to accidentally also hurt human cells, and how well they could sneak through a bacteria's outer defenses. They also got rid of a lot of molecules that were so similar in structure to each other that testing them all would be redundant. Eventually, researchers ended up with 22 synthesized and purified molecules, and of those, 6 displayed antibiotic properties. When they subjected one of those chemicals to further testing, they found that it actually killed bacteria faster than the existing first-choice antibiotic. Even when researchers actively encouraged bacteria in their labs to evolve a way to resist it, they were unable to do so, suggesting a very promising head start on evolution. Finally, and most excitingly, this computer-designed antibiotic worked against 10 different strains of bacteria that had previously evolved resistance to existing medications. This study not only gave us new candidate antibiotics, it also gave us a pool of brand new chemical structures that we can study for how they work and use that information to design even more drugs. And all of this came from a responsible, ethical, and scientifically sound use of generative AI.